Hi, everybody. We are on exponential growth and decay. So, yes, today is primarily word problems, but that's okay. I think you guys will enjoy it today. It's one of my favorite lessons we do all year, so be excited with me, please. So, we're going to have our exponential functions, which we've been working with, but we're going to put it to a word problem, okay? So, that's what we're going to do. We're not going to use this foldable. I don't like it. I don't like how it's set up. So we're not going to do it. We're just going to do these examples together that are in our note packet. So we have some real life examples to our exponential functions we've been talking about. So our first one says, your great uncle Larry bought a speedboat. If he originally paid $189,000 for it and it depreciates 20% per year, how much will it be worth in 10 years? So we have this formula, okay? So we're gonna have y equals, because that's what it always is, our original amount times our rate times our time, okay? And now this is kind of like your just generic formula. Now we're gonna plug into it. So the first part's pretty easy. Your original amount is A value. Well, how much did Uncle Larry pay you for his speedboat? He paid $189,000. So we're going to have $189,000 times our rate. Now we have to figure out what our rate is. So let's think about a few things here. So we know it's depreciating at 20% per year. Well, everything starts at 100%, right? 100%. That's what something is starting at. And now if I depreciate, that means I'm going down. I'm losing value. And I'm doing so at 20% per year. So I'm losing 20%. So now what's 100% minus 20%, you guys? That's 80%. But now 80%, what is that as a decimal? We don't want to put a percent in our formula. We want a decimal. So 80% is really, I don't want to use yellow, sorry folks, 0.8. That's 80%. So now if I come back to my equation here, I'm going to take my original amount times my rate of 0.8. That's my rate, my R. And now the T is how much time? Well, in our thing, it says, our problem, it says how much it will be worth in 10 years. So that's my time. So again, just to break this down quick for this first one, our original amount that Uncle Larry paid was $189,000. We figured out what our rate was, and then for the amount of time. And now, folks, this is just simple calculator work. So in your calculator, you're going to type this in exactly how you see it. 189,000 parentheses times 0.8 end parentheses to the power of 10. Okay? So now, folks, you should get an answer of 20,293.72. So since it's money, we can go to two decimal places, but that's pretty crazy. So what does this mean? This means after 10 years of owning a boat, Uncle Larry, the value is only worth $20,000. Okay? So again, every problem's going to kind of start off the same way. Okay, let's try another one here. So again, I'm just going to write down our generic formula. Okay. So if we read this question here, I'm going to sneeze, I'm sorry if I do. It says, the flu virus is spreading around GFC. At the moment, 500 students are infected. If the virus is spreading at a rate of 25% each day, how many students will have caught the virus in 2 weeks from today? So remember, we got to do, what is our starting amount? Well, our starting amount was how many students? 500. Now we have to figure out our rate. Remember, your rate always starts with 100%. And now we're spreading at a rate of 25% each day. So if you're spreading, that's increasing, right? So I'm going to add 25%. Okay, so 100% plus 25% is 125%. Now, what's 125% as a decimal? It's 1.25. Okay, 1.25. So now we can come back to our equation here. Our rate is 1.25. And then our time, well, what does it say? Let's see, how many students have caught the virus in 2 weeks? Well, how many days is 2 weeks? Well, 2 times 7 is 14. Okay, and now folks, again, it's just calculator work. So in your calculator, you're going to hit 500 times 1.25 in parentheses to the power of 14. And we should be getting an answer of 11,360. Should probably round up because we can't have 0.6 of a person. Students. Well, folks, if we had a virus or the flu that was infecting at a rate of 25% each day, 11,000 students, that would be all of UND's campus. That would be incredible. That would be more than our district has students. I think our district only has 7,000 students. So that would be, it's probably like COVID, you guys. We probably could use the word COVID here instead of the flu. So something just to note real quick, you guys, since we're looking at these two examples. If your rate, so if we look here, you guys, I'm going to pick a color we don't have. Orange. So if your rate is less than 1, you're decaying. If your rate is bigger than 1, it's growth. Okay, so that's how you can tell. If you were just to look at an equation and you're looking at your growth or decay factor, if it's less than 1, it's decay. If it's bigger than 1, it's growth. So we could be fancy here. I'm just going to give you an example. If you had y equals 5 times 0.68 to the power of t, you would be able to tell right now that this is a decay, an exponential decay, because 0.68 is less than 1. But if you had y equals 10 times 1.7 to the t, you could tell that this was growth because this number 1.7 is greater than 1, okay? Will you do these two examples on the back of your packet for me? We'll do them together, but on the very back of your packet where there's just that blank page, let's just do these. You don't have to write them out, but just want you to write out the math, okay? Let's just write out the math just for a few extra examples here. So this one says the number of students at a local high school is 300 and is increasing at a rate of 8% per year. Write an exponential function to model the situation. Then find the number of student athletes after 5 years. So again, our formula. First got to figure out what's our initial value. How many student athletes do we have right now? We have 300. So we have 300. Now we have to figure out our rate. Remember, you always start with 100%. And it says we're increasing at a rate of 8%. So I know I'm going to add 8%. So I'm now at 108%. That as a decimal is 1.08. So that's our rate. And then our time, after how many years do you want to figure this out? After 5 years. Now, folks, again, this is just calculator work. Type it in exactly how you see it. 300 times 1.08 to the power of 5. So after 5 years, we are expected to have 400, and 480 should be round to 1 since we can't have 0.79 of a person. Student athletes. Perfect. Good job. Okay, I think you guys should pause the video and try this one on your own, okay? So read it, write your equation, and then check back with me, okay? All right, I'm going to do it right now, so I hope you tried it. So here we go. It says a population of fish starts at 8,000 and decreases by 6% per year. Write an exponential function to find the population of fish in 10 years. So again, what's our initial amount? We're starting with 8,000. We have to figure out our rate. We know we start with 100%, and we're decreasing by 6 every year, so minus 6%. Well, 100 minus 6, you guys, is what? 94%. 94% as a decimal is 0.94. Plug that into my function up here. And we want to figure out what will our population be after 10 years. There's our 10. Here's plug it into our formula for our t. Now here we go. Calculator work. Type it in. 8,000 times 0.94 to the power of 10 equals, yikes. It's not looking good for whatever body of water these people are in, or these fish are in. 4,300, let's round up, 09. Round up the nearest whole number, fish. So after 10 years, it's almost half of what it was. So either there's some really good fishermen there, or something goofy's going on in that water. Okay, thank you again for watching this video lesson, folks, and that's all I have. Okay, goodbye.